Welcome. My name is Michael Clark. I'm an IT operations and tech industry consultant with Renaissance Tech and Media, where we help companies and organizations struggling with cybersecurity challenges to operate more safely, securely, and efficiently in the world of hybrid multi-cloud computing. Today, I'm here with Brett Hamill, Senior Solutions Architect at Genians, a company that has helped over 1,600 customers around the world since 2005 to secure their network edge. Nowadays, old-fashioned security methods like perimeter-based and agent-based security are no longer sufficient to secure all connected devices dynamically across the network. So we have to rethink how best to secure the network edge, which remains a major cybersecurity point of vulnerability. Now, obviously, without a solid NAC architecture, we cannot fortify the network edge to secure all network-enabled devices, especially in the IoT era. With numerous NAC solutions and architectures available on the market today, failing to take architecture and design into account when selecting a NAC solution can be a costly mistake. So today we're going to discuss how different NAC architectures can impact your business and what can be the best way to solve this challenge. With that, I'm going to turn things over to Brett from Genians to begin our presentation.
Thank you, Michael, and thank you everyone for joining today. If this is your first webinar, this is part of a series, so we cover various topics on these series. This particular webinar is going to be talking about very briefly how NAC can enhance cybersecurity strategy. We talked a little bit more about that in our very first webinar, NAC 101 webinar, which is available at our Genians YouTube channel if you'd like to look at that. This is actually the third webinar in this series. The bulk of the time will be used to talk about the best approach for multi-layered access control. So in that section, we'll be talking about different NAC architectures and reviewing them. We'll be talking about layer 3 architectures, layer 2 architectures, as well as the pros and cons of the various architectures available. We'll wrap up by talking about how NAC rapid deployment is critical for your network security. And we'll talk about NAC project timelines and how those are key to a successful deployment. So we'll start off talking about how does NAC enhance cybersecurity. We'll touch on this briefly. We did go into this a little bit more in depth in our inaugural session for this webinar series. Stated here in this matrix is a list of the Center of Internet Security basic controls for various regulatory compliances. Really what this depicts here is that no matter what market you are in or your customers are in, there's going to be one or more regulatory compliances that you're likely subject to. These basic controls are some of the common and most important controls that are common across all the different regulatory compliances. So the goal is if you put these in place, you're going to drastically reduce your chances of suffering an attack or having some kind of a compromise. So what we're going to look at is how NAC can actually help facilitate these controls. If we examine the controls that we looked at its previous page, and we look at the features network access control can provide, there's going to be a very obvious correlation about how the different network access control features can help solve each one of these common requirements. So whether you're talking about inventory control of hardware or software, there's going to be a NAC feature that correlates to that. So NAC can detect IP-enabled devices on the network, identify what kind of device type those are, and can also identify what kind of software is installed on the device, typically through an agent. Additionally, vulnerability management is very important. Some NAC solutions require third-party integrations, but regardless, you should be able to manage vulnerabilities on your network with whatever solution you provide. Controlling access and privileges, that's a core component of network access control to be able to authorize devices and users and then assign privileges based on various criteria, such as device type, ownership, role, etc. secure hardware and software on your endpoints. So being able to actually secure what software is run and even secure what hardware can be enabled, that's typically a key function of any good NAC agent. And lastly, being able to monitor and have an audit trail is a key requirement as well. So you'll want to ensure that your NAC solution has all the appropriate history and audit trails available to meet that requirement. So it's fairly obvious here that network access control is a good product and lines up well to meet these common core cybersecurity requirements. So 3 critical steps for cybersecurity. These match up with the building blocks of any solid network access control solution. We spoke at length in previous webinars about the surveillance and detection aspects of network access control. Today, since we're going to be talking about architectures, that's really the control piece and how you can actually control devices that connect to your network. In other words, what methods will you be using to do that? And that's relative to the NAC architecture. In the future, in our webinar series, we'll be talking more about automation, which is really integration with third-party systems, SIMs, next-generation firewalls, etc. With network access control, there's some basic functionality that we can talk about here. Really what you want to do is classify your devices on your network, apply that to enforcement policies, and then assign permissions. So for example, and this is going to vary product to product, with Genians NAC, you have over 500 different conditions that you can use to very specifically in a very granular fashion group your devices together. And that helps you then define more granular enforcement policies and permissions. Now, how you actually facilitate that on the network is really the bulk of what we'll be talking about today. So there's different layers of security with different types of network integration methods. And we're going to be talking about all of these. So these are some of the most common methods that are used when integrating a network access control solution into your network. What we're going to do when we talk about these is we're going to look at them and then we're going to put up for discussion what is the best approach for NAC integration. There's so many different ways that you can integrate various NAC products into your network. We want to look at the pros and cons of those and differentiate the different types of architectures so you can make the best decision. This matrix is one of the most important pieces of information in this presentation in this webinar. This is an overview of all the various considerations that network managers and security professionals should take into account when deciding what type of NAC architecture to implement on their network. We've chosen these 5 as these are the most 5 common deployment methods and architectures out in the market today, and they represent the vast majority of NAC implementations that are in production. Looking at this, green is good. So anything you see here that's green, that is an advantage, and that helps you with these considerations that are listed here. So if you take a few of these, for example, does the NAC architecture you're implementing require you to update every switch configuration? So you can see for some of these, that's actually true, and for others, it's not. And then, do you have to add every switch or every network device to your system, so to your NAC policy server, radius server, what have you, and so on and so on? Is there a single point of failure with that particular architecture when it's introduced? Does that mean you need high availability? Is the solution vendor agnostic? And we'll talk more about what it means to be truly vendor agnostic. That is one of the most overused terms in the NAC industry. Are minimum switch features required to implement whatever kind of architecture you're going to implement? Do you have to schedule downtime? If you refresh your network, will you have to reintegrate or replace or update or change your NAC architecture? Does it introduce any throughput or capacity concerns? Can it be cloud managed? Is it low touch or zero touch provisioning? Do you need to have NAC systems or appliances at every location? And what type of hardware can you use if that is the case? So this is a sort of a guideline to have you, in a very brief snapshot, look at the pros and cons of these different solutions. But we're going to go in and we're going to dig a little bit deeper and look at these various architectures a little more closely. We're going to start with Radius because Radius is one of the most predominant ways to implement NAC in the marketplace today. It's very popular. I've been in the NAC industry for about 16 years and spent the last several of those years focusing primarily on Radius NAC deployments. So very common. That being said, full of all sorts of challenges. So if we look at a couple of these challenges, when you implement Radius, essentially every single network device is going to have to support the features required. So different capabilities with Radius, whether you're talking about authentication or post-authentication authorization, or basically Radius-based NAC, that's going to require additional features above and beyond authentication. So depending on how old, for example, your switching infrastructure may be, or what kind of a wireless infrastructure you may have, will depend on whether or not all of those features are supported. So that's a major consideration for this particular architecture. Every single switch, controller, or access point, depending on what kind of wireless architecture you have, must be touched in order to implement Radius. So all of these network devices that are in your network become Radius clients to the Radius server. So that means configuration of all of those devices. In addition to that, you have to add all these devices to the Radius server. So your Radius server must be aware of all of these devices and must be configured to allow these devices to authenticate devices that are connecting to them. Within the implementation of Radius, you're also introducing a single point of failure, meaning if your Radius server goes down, typically you're either going to lose network access or your users will, if not losing network access altogether, have to be shunted off to a failover VLAN or some kind of a less desirable network access than they would have in full production. Because of that, high availability is almost always implemented, and that, of course, increases complexity and more configuration, and that makes for a longer deployment. Even just to get basic visibility with Radius, you have to enable authentication to get Radius accounting so you can actually see devices on the network. So you have to go in there and turn on authentication to get that kind of visibility. Additionally, I talked about the term vendor agnostic earlier being overused. No matter what you're told, Radius-based enforcement for NAC is typically not vendor agnostic. There's going to be certain switches, makes, models that are supported, some that are not. And then even if you change that out, you may have to modify those configurations. Another popular architecture is SNMP to implement NAC. There's going to be some commonality between SNMP and Radius. You have to have SNMP capable devices. Those are more predominant than Radius capable devices, but still a consideration. And then some of the other things we talked about for Radius are still true. You still have to configure all those devices. You still have to add all those devices to your policy server. And you typically still have to configure high availability because you have a single point of failure. So if you have a NAC policy server that's issuing SNMP commands to your various network devices, and it actually quarantines a device, and then it goes down, that device will be stuck in quarantine. So just like with Radius, you really have to implement high availability. So while it may not be as complex as Radius, it's going to rely primarily on VLANs for quarantine or for network access. So that means VLAN configurations must line up with your NAC policy configurations, and the VLANs have to be restricted based on the level of access you want to assign to those roles. And then layer 3 devices on the network, whether it be a core router or a firewall, actually do the network segregation. So now, in addition to configuring all of your other devices, there may be some layer 3 ACLs that must be configured, managed, updated, and maintained for this type of architecture. If we look at another common NAC architecture, you have mirror/span, whichever you'd like to call it. So a little less complex than Radius and SNMP. However, we now have a new set of challenges, right? Of course, your devices have to support port mirroring and span, which of course many devices do, but not all. On top of that, now throughput is a concern. So in very dense network environments with large amounts of VLANs or users, you're basically going to mirror all this traffic over to your policy server. Now performance is an issue on the policy server, so it may require a higher level policy server or multiple interfaces that get lagged together. And so really that could increase complexity and cost. Also, typically span is not viable in most cases for remote sites that are segregated by an internet connection. So therefore, now with your remote sites, you have to have a policy server at every remote site doing the span enforcement. So you still have some network configuration you have to do. Environment of the network is going to be a factor because it's affected by volume on the network. And when you're all done with that, essentially you have a layer 3 enforcement model instead of layer 2. So all of your east-west traffic between nodes is not quarantined or isolated, and you cannot enforce policy. If I go way back in history, I spent the first several years of my career in the NAC industry doing inline deployments, which were more popular back when. So inline deployments, while on one hand eliminate many of the challenges with some of the other architectures we talked about, it actually introduces a whole new set of problems to deal with. So now your actual policy server or gateway becomes part of the network infrastructure. That means it's going to be installed, typically layer 3 inline into the existing network somewhere, normally at a choke point or an aggregation point. That now means you have to require downtime and schedule that to actually insert this device into your network. And again, throughput now is a concern. So you have to be able to handle the capacity of that traffic, and you've also introduced a single point of failure. Also, depending on your routing, in other words, if your branches have their own internet access and don't connect back to the HQ through a wide area network, now you have to have a policy server gateway at every branch. So you've got all those concerns. And then on top of that, again, you're left with layer 3 enforcement. This is actually typically worse than the mirror from the standpoint that not only will east-west traffic not be blocked, but even inter-VLAN traffic also is not blocked. So devices on the same segment, devices on different VLANs, if they're south of the policy server or gateway on the network, basically are not subject to policy. So what we're doing is we're looking at all those very common architectures, and we're going to contrast those with the Genians ARP enforcement architecture, which uses network sensor technology. So some of the things that I like about this architecture, having deployed many of the other architectures in the past, is the fact that you don't have all the requirements that you have before. So you have a policy server that can be physical or virtual on-prem. You can also host that in the Genians cloud. You do not have any requirements of your network environment to support Radius or SNMP or port mirroring or anything else. So it almost makes the network environment irrelevant. Because of that, you don't have to go out and configure your switches, your controllers, or your access points. No configurations required for the policy enforcement portion of the integration. High availability is also much less common with this type of architecture because this architecture will fail open and not closed. And any network manager will tell you the only thing more important than network security is network availability. So you want to make sure people can access the network. And this system will fail open, allowing that to occur. Going back to the vendor agnostic term I talked about earlier, this is actually truly vendor agnostic. And the reason that could be said with confidence is because ARP is the technology that is leveraged, and the particular make, model, vendor of the network infrastructure is not relevant. While it may change, ARP is consistent through all of those different network components. So that is what makes this enforcement model truly vendor agnostic. And lastly, it can be very rapidly deployed, not because it's magic, but because you've taken away all of the barriers that slow down a NAC deployment and cause them to take a long time and to be difficult to deploy and manage. Whether you deploy sensors at your branches or your HQ will depend on your network topology, but one sensor can monitor and enforce up to 128 VLANs per sensor, and there's active and passive modes available, which we'll discuss here in a moment.
Hey, Brett, Michael here. So I believe your diagram makes this clear, but I just wanted to confirm so that everyone has this. Will ARP enforcement work on both wired and wireless networks? And what about IoT situations?
Yes, absolutely. So the fact that ARP is the key technology that's being leveraged means that that's consistent through wired and wireless. So essentially, every wireless network ultimately terminates back to a VLAN on the wired network. So that means that there's going to be a segment that can be monitored by the sensor. And in that segment, we're going to see the ARP traffic necessary to both monitor and enforce. That means it's the same for wired, wireless, or IoT devices. So we'll talk a little bit now about how ARP enforcement works. We talked about the network sensor component and where that fits into the overall architecture. So we'll talk about the network sensor modes. The default mode is a monitor mode. What that means is device platform intelligence, which is the Genian NAC next gen device fingerprinting, is collected automatically as soon as the sensor is connected to the network. So in monitor mode, there's no configuration required, and it's going to use all sorts of different traffic that it's both monitoring passively on the network, as well as doing some scanning on the network and correlating all this information to come up with a device platform. And that's what your devices are tied to. We'll show you that a little bit later in the webinar. Also, because of the visibility at the layer 2 level, network anomalies such as ARP bombs, other devices out there doing ARP poisoning, or DHCP conflicts can all be detected and remedied using this enforcement model. Once you switch to enforcement mode, it will start enforcing all enabled NAC policies and facilitate layer 2 quarantine via ARP enforcement. So this is ideal for the ability to implement NAC in phases, which is always recommended, where you first start with visibility and then you follow that with enforcement. And again, other than connecting your sensor to a trunk port and tagging VLANs, there is no network integration required for this functionality. Your ARP enforcement can block internet or east-west traffic on the same segment, and as a reminder again, it fails open. This is a visual depiction of what the ARP enforcement looks like. So one of the key things to note here is when a node is trying to IP route out to other nodes on the network, it's going to get an ARP reply packet from Genians and redirect non-compliant traffic. So the key here is that the network infrastructure is not really part of this exchange, and its Genians is leveraging ARP and not the network device to enforce policy.
You know, Brett, this raises another question for me anyway. In the event that a complete network refresh were to take place, you know, at the hardware level, will ARP enforcement still function after, say, all the switches, for instance, have been replaced?
Absolutely. You'll notice this exchange, this is all through ARP and ARP replies, which is what the endpoint is going to use to route on the network and communicate with other devices. Does not require any hooks into this layer 2 device here. So whether that's wire to wireless, once that actually gets replaced then you don't have to make any additional changes. This will continue to function uninterrupted if you were to replace this switch, for example.
Right, right. So I assume the same goes for the wireless infrastructure as well. If in the event that all the wireless controllers and access points or some subset of them were to be replaced?
That's correct. Really, the wireless network infrastructure is still layer 2 infrastructure. And the great thing about ARP is it's the same for wired or wireless. So it really doesn't matter if this is a switch or if this is a wireless controller or an access point that gets replaced. It actually will not affect this integration.
Okay. Yeah, as I thought. Roger that. So last question, I promise. What happens if the sensor fails? I believe you said earlier that it fails open. Just want to make sure that's clear for folks.
That's correct. So if your sensor were to go offline, the ARP table is going to refresh on this endpoint. So it's going to fail open typically in about a minute. For example, there's an algorithm that gets run on a Windows device that determines how long it will take to refresh its ARP table, and it's going to be 40, 45, 47 seconds, something like that. It varies a little bit, but it'll fail open if anything happens to these sensors. So we now have compared different types of architectures, and although all the different kinds of architectures that we mentioned are supported by a Genian NAC solution, which comes with a built-in radius server, SNMP capability, mirror capability, etc. ARP enforcement really, we believe, is the superior architecture, and not only because it removes some of the challenges, but because the rapid deployment is possible. So we talked about being able to deploy quickly. So if we think about what makes a NAC implementation successful, it's really removing those challenges, those barriers. Computer Weekly has done a study that talks about all sorts of various challenges with implementing NAC. 3 of the top 5 are related to integration and complexity. So whether you're talking about integrating with your switches and not having the right switches or some kind of incompatibility, or whether it just becomes too complex, which of course in turn takes a long time, now you have a much higher probability of a failure. But if you look at this, some of the comments in this study: barriers of complexity, interoperability, high total cost of ownership. Organizations may have to upgrade their switching gear to able to implement NAC effectively, and then they would have to manage it all, which introduces complexity. So it's a common theme you hear over and over with many of the different architectures, and we believe that ARP enforcement really eliminates a lot of these. So the sad truth when it comes to NAC is that these challenges make your deployments longer, and the longer the deployment is, the higher probability you have that it just doesn't complete or it just fails entirely. So I actually personally have seen security managers and IT managers decide just not to purchase NAC just because of these challenges, or even worse, I've actually seen them purchase and just never deploy the product, even after paying for it, sometimes even renewing maintenance cycles because it just became too complex. And ultimately what that means is you have just your perimeter security, which we all know today is not sufficient. So one of the things we're going to talk about a little bit more is being able to rapidly deploy. So we know that you have to be able to rapidly deploy to really have that high probability of success. So we're going to talk about some of the steps that would be required to deploy a Genian NAC solution after quickly doing a demo on how quick we can actually deploy it. So under your trial and buy section on Genians.com, you can plug in a cloud site name, select your edition, and create your own cloud site. So this takes roughly 3 minutes to create. So while we're waiting for that cloud site to create in real time, we'll go back and talk about this a little bit. In order to get to where I was, you simply have to go in, sign up at Genians.com, log in with your account, and then click the button I just clicked. And what we're going to show you in a few minutes is that that cloud server is going to be provisioned on the Genians AWS infrastructure. So it's going to look at your source IP, it's going to provision a cloud instance and your particular availability zone, and then after that, you're going to have a functioning cloud policy server you'll be able to log into. Now, if you recall the architecture, there's two components. There's the policy server and there's the network sensor. So once you have your cloud policy server deployed, which can be done very quickly, you can then install your network sensor. This ISO image can be downloaded and it can be installed virtually or physically. And then once you install that, we recommend virtual if you want to do a quick POC or just look at the system. It'll automatically start detecting nodes. In other words, you don't have to do any policy configuration. With most systems, even to get basic visibility, you have to configure some kind of default MAC policies in order to see anything. That's actually not true here. So it's very, although it's not zero touch, it is very low touch. It's almost zero touch to get that deployed. There are instructional videos on our YouTube channel that actually show you how to do both of these, the cloud policy server, as well as installing the ISO image into your environment, linking the two up, and then looking at the nodes on your network. So 15, maybe 20 minutes, depending, that's all you need. So we'll go back and look at this. So again, we've got an AWS cloud site that's being provisioned. As soon as this is provisioned, there's going to be an email sent to the account you're logged in with that will give you some of the information we're going to see here in a minute, which will include your site name. It's going to include the account. It's going to include the edition that you actually purchased, the number of endpoints that you can test with, and then when your cloud site expires. Once you have that information and your cloud site is active, you'll be able to log in to the cloud site via its UI and view the UI and then add your network sensor to the UI. Once that's completed, it'll basically look like this. So this is a fully deployed system, and you can see we're detecting all sorts of information here. In this system, this is a cloud instance here, and in this system, which we're going to show you, we have some sensors that are actually linked up with this cloud policy server. So we have a sensor in our Boston headquarters, and that sensor is what is detecting all the information that you see on the network here, which we'll talk about briefly to wrap up our webinar today. In the meantime, we can see here that this has completed. It takes roughly 3 minutes to complete. This is the page that pops up, and this gives you all the information about the cloud site that you created along with the URL. You'll also get an email as well with this information. If you click on that, it'll take you to URL. Once you log in, you're actually going to get an end user license agreement. You'll get prompted for some information. This is optional, SNMP, SSID information, time zone information. That's all optional. And this is it. So this is actually the cloud site that I just turned up. So in under 5 minutes, we have a functional cloud site. You're going to have instructions here on how to download that sensor ISO image I talked about a moment ago, along with instructions on how to actually link up that sensor to your cloud policy server. So while this shows all zeros now, and we actually don't see any sensors that are linked up to this, once you link up a sensor to this, it'll start populating with information. And again, on the Genians YouTube channel, we actually have a couple of instructional videos to show you how to do that. 15, 20 minutes, you can have this whole thing up and running. Once that information starts populating, you're going to get information about these nodes, very detailed information. You're going to get connectivity information. You're going to get information about whether there's agents installed, whether it's active, connectivity graph, IP, including IPv6 information, MAC address, platform information, location, the percentage of time it's been online, if it's part of a domain, 802.1x, VLAN ID, SSID, all sorts of great information. One other thing that you're going to get here that you'll actually not get with any other NAC solution that I'm aware of is what we call device platform intelligence. This is going to give you a physical image of the device, not just the manufacturer, but the manufacturer, make, model, what type of device it is, how it was fingerprinted. You're also going to get any vulnerabilities that are actually linked to this device. So we've already pre-correlated any possible CVE that could be linked to this platform type, meaning without a vulnerability scanner, you're still going to have this information. This information that you're seeing here is all maintained in the Device Platform Intelligence Cloud. This is maintained by a team of DevOps engineers and shows you all sorts of different platforms, and we're adding to this all the time. So every week, this gets updated. In addition to that, there's a built-in DHCP server. So even without using this system as a DHCP server, you have visibility into all the IP addresses that are assigned. Now, why is that? The reason is that we have layer 2 visibility. We're monitoring all the ARP traffic. We can see DHCP requests that are coming out. So when a device actually takes an IP address as its own, we'll actually see that, and we'll be able to link that back to a node. And then, of course, you can use full DHCP server functionality. You can also enable conflict prevention. Remember earlier what I talked about is we have the ability to resolve conflicts because we can see when a device comes on the network with an IP, if another device comes on behind it, we're able to resolve that conflict. There's also switch management functionality. This is optional, but if you enable SNMP on your devices, you can monitor your devices and you can look and see what type of devices are connected to every port, all sorts of information that you can get, anything available through SNMP you can get. This is optional. This is not required for ARP enforcement. This is just a free module that is in there that you're able to leverage. In addition to that, sensors can have wireless interfaces in them. So remember, layer 2 means wired and wireless. So those are the same for us. If your sensor actually has a wireless NIC inside of it, then it's able to see all of the SSIDs because it's monitoring the wireless signals and all the wireless traffic. So what you're able to get is the MAC addresses, the SSIDs, the MAC addresses of all the wireless devices out there, what the vendor is, security settings, and all sorts of other information about these particular SSIDs. In addition to that, because we are monitoring both wired and wireless networks, we can determine which SSIDs are internal and which are external. And we can do that by comparing MAC addresses. So what we can do is allow you to enforce policy based on internal SSIDs or external SSIDs. In addition to that, one last thing to take a look at is that we have a captive portal that can be completely customized. It comes out of the box with a default configuration, but you can actually customize the captive portal by turning on and off buttons or editing the content. And then lastly, there's a Radius server that is built into the system, free. If you wanted to use Radius instead of ARP enforcement, you can do all the functionality that you would do with any other Radius server, including certificate authentication, VLAN assignment, etc. So the key here is to remember that these capabilities exist. You could choose your architecture, but the ARP enforcement architecture, which doesn't require any additional configuration, is what we actually see as the most beneficial.
And as you said, Brett, you had that up and running in how long?
Right, so that was a live demo, and but we encourage you to actually check it out yourself and to test this out and see how quickly you can get this up and running. And based on that, I want to see if there are any other questions on any of the content that we presented today.
Yeah, people will remember that we do have a Q&A section at the bottom of the screen, but we've had a few items have come in. First one, in the meantime, since we started, does the virtual sensor have to be deployed, Brett, in a VMware ESX environment, or can it be installed in a different virtual environment, such as VirtualBox?
It actually can be installed in various environments. So when you download the ISO image for a sensor, it's up to you whether you actually take that and install it in an ESX environment or a VirtualBox environment. I even have a sensor installed on my laptop running VMware Workstation. So it's very easy to import that. Or if you want to install that on a physical device any Intel-based machine that meets the minimum hardware specs, which are listed on our website, you can install that image on. We have customers that use small form factor Intel NUC type or mini PC devices for sensors.
All right, and one further question that I see, just confirming that Genians supports all of the enforcement methods covered earlier, right? And if so, can any of them be mixed in a deployment?
That's a great question. So one of the things we talked about, of course, was all the different architecture methods, or architectures that are out there. And we did talk about the pros and cons of these. That being said, Genians actually can deliver any one of these. The vast majority of our customers use the sensor technology because they've tried all the others and they find it easier to use. So it's by far the most popular architecture that we deploy. But the rest are available if it's something you desire. They can also be mixed. So I'll give you an example. One of the biggest problems with Radius is really the authentication is difficult to set up, but the post-authentication authorization or your Radius-based NAC, that's where a lot of the complexity comes in because you're pushing Radius attributes to your switches. You have to do a change of authorization, and it becomes much more complex. So we do have some customers that actually authenticate using Radius, but they don't do NAC enforcement using Radius. Once a device is authenticated using Radius, then ARP enforcement is used when you have to quarantine or you have to restrict access to a device because you don't have to worry about all of those Radius attributes and ACLs and all that complex configuration.